I'm going to take you, what I'd like to do over the next 45 minutes is to take you to my world, to take you into the deep sea in a journey of exploration and discovery. And I hope that after the evening's over, you walk out of the room saying, I didn't know that, and I didn't know that, and I didn't know that. And I hope that when you look out at the ocean the next time you do, you'll look at it in a very entirely different way. Now, for many, many years, as I've been doing deep sea exploration, in my early part of my career, the only way that I could actually get to work was to get in a deep diving submarine, like the one we had at Woods Hole, or still is at Woods Hole, the Alvin. And Alvin is a deep diving submarine. It goes to 16,000 feet. The average depth of the ocean is 12,000 feet, so it can get a fair amount of real estate down there. And when you go down, you have to realize how small these vehicles are. And let me show you a picture of the inside of our sphere. Now, this was shot with a fisheye lens, so it gives you a much distorted image of what it's like. I'm 6'2", and that sphere, top to bottom, is 6 feet. So that's the hatch. I cannot stand up. So it looks like it's really roomy, but it's not. Now, when you go down in these deep diving submarines, there's 3 people inside. There's a pilot with a great deal of experience, a senior observer also with a great deal of experience. But it's very common when you make a dive to take someone who has absolutely never done it before. And you take them on their first deep sea dive. And that's so much fun because you have this great initiation you go through. One of them is that there's no bathroom in the submarine. Now, when you're out at sea diving and you're in what we call the dive cycle, you tend to dive every other day. And so when you know you're going to dive the night before, you dehydrate. You don't drink anything, and you don't drink anything in the morning. But you're filling the novice with coffee all morning. And about 45 minutes into the dive, they do have a problem, but I won't go down that road any further. The other thing that's really interesting, and this picture really doesn't show you, is the temperature. See, the submarine is made out of titanium, and so it's sitting on the deck of the ship all morning, and it just gets super hot. And so when you crawl down in the hatch and seal yourself in, the temperature is in the 90s. Not only is the temperature in the 90s, the humidity is in the 90s. So it's basically like crawling inside of a sauna and sealing yourself in, and then having them take the sauna and throw it in a washing machine called the ocean. And what you then do is you're just absolutely uncomfortable. It's extremely hot. You peel off your clothes and you wait. Now, there's an interesting thing that occurs because as you fall down to the ocean bottom, let's say we're going to go 12,000 feet, which is a typical dive. We're going to go down 12,000 feet. It's going to take us 2.5 hours to get down to 12,000 feet. Now, during that free fall, the temperature outside the submarine plummets to where it's near freezing. It gets down to about 4 degrees centigrade, which is a hurtful cold. If you put your hand, absolute hurtful cold. So here's what happens, that the ocean is a gigantic body of water, and it just is like a heat sink, and it just sucks the heat out of your submarine. And your temperature plummets, and you start really trembling. Well, here's what happens. That warm, moist air begins to condense on the hull of the submarine. And give me my slide back. It begins to drip, okay? Now, you know it's going to drip. The pilot knows it's going to drip. It's one of those other things you fail to mention to the novice. In fact, you place the novice directly beneath the hatch, tell him to look out the window, and you wait. Now, in fact, you and the pilot sort of take a side bet on how many drips it's going to take to crack this macho individual. It takes about 8 drips, okay? But it takes 45 minutes for this physics to manifest itself inside the submarine. So by the time the first drip starts to fall on their head, you're down about 5,000 feet. You're about a mile down, and that first drip falls on their head, followed by the second, the third. And sure enough, around the 8th drip, they're squirming. And they're getting flashlights, and they're searching, because you turned off all the lights and let them sit there with a drip on their head. And they start searching for the drip. Well, naturally, it's right above them, right around the hatch, and they put the two together. And then you hear them clear their voice, in a very You know, I don't want to be an alarmist, they commonly say. I don't want to be alarmist. Have any of you guys notice that there's water coming in around the hatch? And our response is always, oh my God, we're going to die. Now, if you were to put this mountain range on an equal area projection, which this is a Mercator projection, as you know, Mercator projections distort high latitudes, you would find that the mid-ocean ridge covers 23% of the Earth's total surface area. Yet we didn't know it existed in its totality until 1960. And we didn't go to the largest feature on Earth until after Neil Armstrong and Buzz Aldrin went to the moon. We sent humans to the moon, we played golf up there before we went to the largest feature on our own planet, which is quite amazing. And in fact, as we sit here today, the maps we have of Mars, the present maps in the drawer of Mars are 250 times more accurate than our maps of the southern hemisphere of planet Earth. We have better maps of Mars, better maps of Venus, better maps of the far side of the moon. The Earth is truly an unexplored frontier. I like to tell young people, and we see a lot of them in the audience tonight, think about what I'm going to tell you. Your generation is going to explore more of Earth than all previous generations combined. You are the generation of explorers. And so, get ready. So anyway, I started building this system, and the first test of this system, the first chance I had, so we had an engineering period from about 1982 to 1985, and we were ready to go to sea. And we decided that we wanted to do something that would demonstrate to the public we'd entered a new era of undersea exploration. So we said, let's take on the Titanic. Our competitors at Scripps, at Lamont, at Columbia University had tried and failed. It was our turn in the puddle, and we went out, and as you know, during the summer of 1985, discovered Titanic in its watery grave, and then came back with our little vehicle, our first little robot. We called our robot, the one we wanted to build, Jason, in memory of Jason and the Argonauts. But we didn't have the big one ready in the summer of 1986, so we built a little one we called it Jason Jr., or JJ. And JJ stole the show. We went down, looked in the windows, went down the grand staircase. More recently, we went back with a new vehicle, Hercules, exploring the Titanic again, in high def this time, comparing what we'd seen 20 years ago to what we're seeing now. And here we are. This was just the last summer on the Titanic. This is where Leonardo was standing right here, the king of the world. But it was amazing. It was like a museum. The deep sea is a giant museum. What was fascinating, not only was the ship itself, but the human element. Children always ask me, what happens to the bodies? They want to know where the bodies go. Well, naturally, the Titanic had a tremendous loss of life, and we can never forget that. And the bodies came raining down and landed. As soon as they land, animals find them, just like if you died in the woods, and the animals eat them. And they expose the skeleton. And there's an interesting thing about the deep sea, is it's undersaturated in calcium carbonate, and the bones dissolve. So all you have as a human signature are their shoes. Every ship I've ever found, I have found shoes, pairs of shoes, where the body used to be. In Germany, and with the Bismarck, it was German boots. In my ancient ships, sandals. On the Lusitania, a mother with her baby's shoes together. The poignant memory that these are very special places. And as you know, I've been deeply opposed to recovery of artifacts from these sites because I don't see anything to be learned from contemporary sites, certainly archaeological sites. I was asked to serve on a commission by the President and Congress on the Ocean Commission. And one of the wonderful things about being an ocean commissioner is you get to write some of the stuff. And I have been so upset about our ocean exploration program and how underfunded it is. It's just peanuts. Our nation's ocean exploration program this fiscal year is a grand total of $13 million to explore the oceans of the world. Good luck. Anyway, we did steal a ship, though. I was able to steal a ship from the Navy, and it's now up in the Todd Shipyard in Seattle. It's been renamed by children, called the Okeanos Explorer, which is Greek for ocean explorer. And I'm putting its mission, kids, this ship's mission. Want to hear a mission? This ship's mission is to go where no one has ever gone before on planet Earth. And it'll be at sea starting August of 2007. It'll be going to sea for 250 days a year. It'll have the most advanced technology our nation can put on it. It'll be linked from our command center back to a building via satellite. I just convinced the people of Rhode Island on a bond issue to build America's first inner space center, what Houston has for outer space. This inner space center is under construction. It will be linked to the ship 24 hours a day. And when we make a discovery, we'll take it from the scientists, will be on Internet 2, is our prime distribution system. Internet 2 is something that's going to enter your lives and revolutionize. If you think Internet 1 had an impact upon society, buckle up. Internet 2 is in the universities, and it's about to spill out. It's spilling out into the schools. Internet 2, I2, go Google it, makes Internet 1 look like a dirt road on the information highway. It has a bandwidth of 10 gigabits. And we're going to travel electronically with this technology. And here we have, this is an expedition. Remember that vision I had of the scientist? This scientist is running our expedition this summer, and there's the chief scientist, Deb Kelly, and her team operating the system. There's our pilot. Oh, by the way, they're 4,000 miles apart. And she's in Seattle, Washington, in complete control of the ship's operation on this Internet 2, and we're also then using it to distribute it to kids. And what we want to do with this exciting technology is turn schools into classrooms of tomorrow, hooked up to this ship of exploration, and I can't think of a better way than in motivating the next generation of scientists and engineers by going where no one has ever gone before on planet Earth. Thank you very much.